एवरीवन, आप सबका फिर से स्वागत है मेरी यूट्यूब के चैनल में। और आज हम पढ़ने जाने वाले हैं एलिमेंट्स ऑफ सिंपल सर्कुलर कर्व। सो बिफोर लर्निंग द एलिमेंट्स ऑफ सिंपल सर्कुलर कर्व, लेट्स डिफाइन अगेन व्हाट इज द सिंपल सर्कुलर कर्व. So a simple circular curve consists of arc of the circle and this curve is tangential to two straight lines of the root. तो सबसे पहले यहाँ पे मान लो यहाँ पे that here two straight intersect at a point I. So this is known as a point of intersection. So suppose these straight A, B and BC intersect at a point I, and that is known as a point of intersection. So again I define this point here as a T1 and this point as a T2. So what is T1? That is point of curvature and T2 is point of tangency. Now this is a back tangent and this is forward tangent. So now what is the back tangent? So back tangent, that is the line before the beginning of the curve. So this is the starting point of curve. So before the beginning of the curve, a tangent line known as a back tangent or the rear tangent. So here in this figure A1 is known as a back tangent. Now if we want to define forward tangent, then the tangent line after the end of the curve is called the forward tangent. So here line T2C is the forward tangent. Now point of intersection, so where the back tangent when produced forward and forward tangent when produced back tangent meet, so that is known as a point of intersections. So these are three simple definitions and these are three also elements of a simple circular curve. Now the fourth is intersection angle. Okay, so what is intersection angle? So this is symbol is phi and that is known as a intersection angle. So the angle between the back tangent, that is AT1, and the forward tangent T2C at I is called the intersection angle. Okay, so now another angle, delta, defined as a delta. So what is delta? Angle of deflection. Angle of deflection. And phi, what is that? Intersection angle. So what is angle of deflections? The angle delta through which the forward tangent deflect. Okay, so forward tangent deflect. So that is known as a deflection angle of the curve. It may be either to the left or the right side. Okay, it is maybe left or right side. Now we have to define PC. So what is PC? That is a point of curvature. Okay, so it is the point on the back tangent at the beginning of the curve where the alignment changes from a tangent to curve, and also known as a point of curve. Okay, point of curvature, if you don't want to say that, it is also known as a point of curve. And PT means point of tangency. So it is the point on the forward tangent at the end of the curve where the alignment changes from a curve to the tangent. Now tangent distance. Okay, so tangent distance or a tangent length. So this tangent length or a tangent distance. So it is the point, it is the distance between the point of curvature T1 and the point of intersection I. Okay, so T1 to I. This distance is known as a tangent length or the tangent distance, and also it is equal to the distance between the point of tangency, that is T2, and the point of intersection I. So this portion. Okay, and here, so both are tangent length or tangent distance and denoted as a capital T. In the later or a next video I explain all the formulas for that, but in this video we have to learn the basic definitions and what are the elements of simple circular curve. So this is capital T, tangent distance. Now length of the curve. Suppose here it is a O, means origin point of the curve. Suppose this is radius R. This is the curve. Okay. So next element is what? Length of the curve. So total length of the curve from the point of curvature. So this point of curvature to the point of tangency T2 is called length of the curve. So from T1 to T2, that circular distance, that is known as a small l, length of the curve. Okay, length of the curve. Now next element is long chord. Long chord, capital L. Long chord, capital L. So the chord joining the point of curvature T1 and the point of tangency is known as the long chord. So this straight distance is known as a long chord, and this distance is known as a length of the curve, small l and capital L. Now normal chord and subchord. So a chord between two successive regular pegs on the curve is known as a normal chord, and when the chord is shorter than the normal chord, that is known as a subchord. So these subchords generally occur at the beginning at the end of the curve. So normal chord and the subchord. Now the next element is mid-ordinate. So what is mid-ordinate? Okay. So let us join this line T1 to T2. Here I am joining this line. Okay. So I divided here this line into point 2 into equal 2 section, that means L by 2 and here L by 2. Okay. So this point on the curve, here I give name, that point is C, and this name is this point as a D. Okay. So this distance, this mid-ordinate, known as a mid-ordinate. So it is the distance between the middle point of the curve and the middle point of the long chord. So this is the middle point of the curve, known as a C, and middle point of the long chord, known as a D. So this distance between C to D, that is known as a mid-ordinate, and it is defined as a capital M. So mid-ordinate, distance between C and D. So what is C? Midpoint of the curve, and what is D? Midpoint of the long chord. Now external distance. Okay, capital E, external distance. So, or you can say apex distance, external distance and the apex distance. So point C to point I, point C to point I, see this distance, point C to I, that is known as a apex distance or external distance, capital E, denoted by. So it is the distance between the point of intersection and the middle point of the curve. So that is known as apex distance or external distance. Okay, so these are the elements of simple circular curve. Okay, so another, suppose if we drawing this straight line, so again this is known as a central angle. which value is equal to the angle of deflection delta, and this delta by 2. Okay, central angle and half that delta by 2. So the value is equal to angle of deflections. So these are the elements of simple circular curve.